Welcome to Mission 3, Lesson 22. Our student objective for this lesson is to find factor pairs for numbers to 100 and use understanding of factors to define prime and composite. So essentially what we're doing today is looking at factors for numbers and determining if a number is prime or composite. Well, what does that mean? Well, let's explain. And actually, let's start by having our friends at Vocabulary sing us a little explanation.
Yeah. Vocabulary. Oh yeah, factors too. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards. Factors go into a bigger number evenly with nothing left over, believe in me. Memorize your times table like an actor. All numbers have one as a factor, cause all numbers can be divided by one with no remainder. That's how it's done. If you have a number and you need to know all its factors, just start the show. We figure out our factors by closing the curtain. Let's try 32, see how it's working. The first combo we can multiply to get 32 is 1 and 32. Write the 1 on the left, 32 over there. Now we try 2 to find the next pair. 2 goes into 32 16 times, so we write the 16 on the right hand side. Next up is 3. Well, let's see, does 3 go into 32? Not evenly, so it's not a factor. But what about 4? That goes in 8 times, yeah, for sure. 5, 6, and 7, they don't go. And now you can see that the curtain is closed. That's all the factors for 32 for sure. Now hit the spotlight for the next show. If a number only has 2 factors, itself and the number 1, then the fact is we call that number prime. Like Optimus Prime, they're one of a kind. 3 is prime, so are 5 and 7. 9's not prime, but there's prime at 11. 101, that's certainly prime, so it's 3,559. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards.
Okay, now that we've been sung to about it and we have a perfect understanding of factors and prime and composite numbers, let's take a look at a couple examples of our own. Okay, so let's say we're given 18, and I was asked to find all the factor pairs of 18 and then determine whether 18 was prime or composite. Well, here's what I do. I take 18 and I just go through at first and I determine all the numbers that I can multiply together to get 18. Okay. I know starting off with every number I can do 1 times whatever the number is. 1 times 18 is 18. Okay. Now what? Well, I know I can do 2 times 9 equals 18. Okay. And then I can do 3 times 6 equals 18. And now I'm going to think, can I do any other numbers? Can I do 4 times the number to get 18? No, I can't do that. Can I do 5 times the number to get 18? No, I can't do that. Can I do 6 times the number to get 18? Yeah, I can do 6 times 3, but that's the same as 3 times 6, so I don't write that down again. Can I do 7 times the number to get 18? Nope. Can I do 8 times the number to get 18? Nope. Can I do 9 times the number to get 18? Yes, but it's 9 times 2, which is the same as 2 times 9. And I can't do 10 times the number to get 18. So this is it. These are all the multiplication equations I can use to get 18. So my factors then of 18, all I'm going to do is I'm going to label the numbers I used. I'm just going to list them. Well, I used 1, 2, and 3. Because you see I used 1, 2, and 3. And then I'm just listing them from least to greatest. And then I used 6. And I used 9. and I used 18. Cross it off. So these, if you were asked what are the factors of 18, these are the factors of 18. 1, 2, 3, 6, 9, 18. Because those are numbers I can multiply together to get 18. Now, I also want to know then, we need to be able to say, is 18 prime or is 18 composite? Well, what's the difference? Again, if a prime number only has two factors in it, and those two factors are going to be 1 and whatever the number is. If those are the only two factors, if there are no other numbers you can multiply together to get that number, then it is a prime number. So I like to remember Optimus Prime, right? Optimus Prime, there can be only one pair of factors is, I imagine what Optimus Prime would say. There can be only one pair of factors. So I always like to think of Optimus Prime there. So in this case, do I have more than the two factors, more than 1 times 18? Yeah, I have a lot more. I have 2, 3, 6, 9. Those are all different factors. So since I have more than just the 1 times 18, this is a composite number. Okay, it's not prime. It's not, there's only one pair of factors. It's a composite number. There's multiple factors to it. Okay, so these are all the factors of 18, and it's composite because of that. Let's take a look at one more. 23. Okay, so I want to determine all the factors. And I need to determine if it's prime or composite. Prime or composite. Okay, so 23. What numbers can I multiply together to get 23? Well, again, to start off with, I know I can do 1 times 23 because I can do 1 times the original number for any one and get 23, or get the original number, excuse me. In this case, it's 1 times 23 equals 23. Now I'm asking myself, what else can I multiply together to get 23? Can I do 2 times? Nope, can't do 2 times any number. Can I do 3 times? 3 times? No, not 3 times. 4 times? No, not 4. 5 times? No, not 5. 6 times? No. 7 times? Nope, not 7. You know what, guys? There are no other numbers I can multiply together to get 23. There are no other numbers besides 1 times 23 that I can multiply together to get 23. So my only factors for 23 are 1 and 23. Okay, so those are my only factors. Now, is that going to be prime or composite? Is that going to be prime or composite? Well, let's see. Remember, prime is if it's only 1 and the original number. Composite if there's more than those 2 pairs. So if we only have the 2 pairs of 1 and the original number, so those are only 2 factor pairs, it is a prime number. There can be only 1 pair of factors. It's prime. It's just me. So in this case, 23 is prime. 23 is prime. Let us take a look at one more here. Hi, Optimus. Hey, guys. Remember, there can be only 1 pair of Optimus primes. 1 pair of factor pairs. Let's take a look at actually one more. And because I want to make sure that we don't get confused on this. Some people get in the tendency of thinking, well, if it's an odd number, it's a prime number. That is not necessarily true. Okay, it's not about odd and even. Now, I can tell you that any even number besides 2 itself, any even number is going to be composite because you can at least go 2 times some number. But it doesn't mean that every odd number, though, is necessarily a prime number. There can be plenty of odd or composite numbers. So let's look at 27. Well, what can I do for 1 and 27? Or to get 27, I can do 1 times 27 equals 27. Now, again, 27 is an odd number. Can I do anything else? Well, yeah. I can do 3 times 9 3 times 9 is 27 as well. Okay, so even though 27 was odd, it has different numbers you can multiply together to get it. Okay, now those are my only ones, so my factors for this would be 1, 3, 9, and 27. But is 27 going to be prime or composite? Well, it's going to be composite, because that's a T. This is a T. Because, look, I have 1, 2, 3, 4. I have 4 factors for 27. So even though 27 is odd, it can still be a composite number. Even though a number is odd, it can still be composite. Don't fall into that trap of thinking it's just about odd and even. But yep, that's what we're working on today. Factors, finding factors for numbers and determining if those numbers are prime or composite.